Good day, everyone. Thank you for being here today. The topic of our presentation is investigating Archimedes' theory for optimizing ship stability through buoyancy. This topic is significant as it delves into the principles of physics and engineering that underpin the design and operation of ships, which are vital components of global trade and transportation. Archimedes, a renowned mathematician and engineer from ancient Greece, made numerous contributions to science, but perhaps his most famous is Archimedes' principle. This principle relates to buoyancy, a key factor in ship stability. In this presentation, we will explore Archimedes' principle in depth, discuss its application in ensuring ship stability, and investigate how it can be used to optimize ship stability through buoyancy. We will also examine real-world examples and case studies to understand its practical applications. Our goal is to provide a comprehensive understanding of this principle and its significance in a ship's design and stability. We hope this presentation will be informative and engaging for all. Archimedes' principle is a fundamental concept in fluid mechanics, named after the ancient Greek mathematician and engineer Archimedes. The principle states that any object wholly or partially immersed in a fluid is buoyed up by a force equal to the weight of the fluid displaced by the object. To break it down, when an object is placed in a fluid like water, it pushes the fluid out of the way or displaces it. The fluid in turn exerts an upward force on the object. This force is what we call buoyancy. The magnitude of this buoyant force is equal to the weight of the fluid that the object has displaced.
Let's discuss the definition and explanation of buoyancy, as well as how it affects objects in water. Buoyancy is the upward force exerted on an object immersed in a fluid, such as water, due to the pressure difference between the top and bottom of the object. This force is a result of Archimedes' principle, which states that the buoyant force on an object is equal to the weight of the fluid it displaces. When an object is placed in a water, it experiences two main forces: its weight due to gravity acting downward and the buoyant force acting upward. The buoyant force is a result of the pressure difference between the top and bottom of the object. The higher pressure at the bottom exerts a greater force pushing the object upward. The magnitude of the buoyant force depends on the volume of the object and the density of the fluid. If the object is denser than the fluid, it will sink because the weight of the object is greater than the buoyant force. If the object is less dense than the fluid, it will float because the buoyant force is greater than the weight of the object. Buoyancy affects objects in water in various ways. Here are few key points. Number 1. Floating. Objects that are less dense than the water will float. The buoyant force acting upward is greater than the weight of the object, allowing it to remain on the surface of the water. Number 2. Sinking. Objects that are denser than the water will sink. The weight of the object is greater than the buoyant force, causing it to descend below the water surface. Number 3. Neutral buoyancy. Some objects, such as submarines or scuba divers, are designed to achieve neutral buoyancy. This means that they neither sink nor float but remain suspended at a specific depth in the water. Number 4. Stability. Buoyancy plays a crucial role in the stability of floating or submerged objects. By carefully managing the distribution of weight and buoyant forces, engineers can ensure that the objects like ships or submarines maintain their stability and do not tip over the capsize.
Most of us have seen an aircraft carrier. You know, the one in which Maverick would land on. Although these ships are composed of metal, are almost the size of a small city and weigh more than 100,000 tons, they still float. How is this possible? It all has to do with buoyancy. Welcome to Moo Math and Science. If you have ever tried to push a beach ball underwater, you know how difficult this can be. This is because the water pushes an upward force against the beach ball. This upward force is called buoyancy, which is the ability of a fluid like water to exert an upward pressure. If you drop an object in water, which is a fluid, then the water level will rise. In other words, the water will be displaced. The weight of this water that is displaced will be equal to the buoyancy force. Archimedes came up with a principle, and in simple terms it states that the buoyancy force of an object is equal to the weight of the fluid displaced by the object. So let's go back to the aircraft carrier. The aircraft carrier displaces an amount of water that is equal to the weight of the carrier, and therefore it floats. Remember the Archimedes principle. The buoyant force is equal to the weight of the displaced water. When you have a large ship like an aircraft carrier on the ocean, you have two forces working in opposite directions. You have gravitational force pushing down on the ship and buoyancy force pushing upward on the ship. Let's keep it simple and use the kilogram. If the mass of the ship is 1,000 kilograms and the mass of the water displaced is 1,000 kilograms or greater, the ship will float. But if something happens and the mass of the ship increases to, say, 2,000 kilograms, it will sink because the gravitational force pushing down on the ship will be greater than the buoyancy force pushing upward on the ship. One way that shipbuilders use to help ships float is by making the ships long with open spaces, which increases the ship's volume, which in turn increases the amount of water displaced, which allows the ship to float.
Certainly, let's explain ship stability and discuss the factors that affect it, including the ship's center of gravity, center of buoyancy, and the mesenteric height. Ship stability refers to the ability of a ship to maintain its equilibrium and return to its original position after being disturbed by external forces such as waves, wind, or cargo movement. It is crucial for the safety and performance of the vessel, as it ensures that the ship remains upright and does not capsize or become unstable. Factors affecting ship stability. Several factors influence the stability of ships. Here are the three key factors. Number one, center of gravity or CG. The center of gravity is the point where the entire weight of the ship can be considered to be concentrated. It is the average position of all the individual weights of the ship's components, including the hull, machinery, cargo, and fuel. Number two, center of buoyancy or CB. The center of buoyancy is the center of the underwater volume of the ship. It is the point where the buoyant force acts vertically upward. The center of buoyancy changes as the ship's hull movements through the water. Number three, metacentric height or GM. Metacentric height is a measure of the initial stability of a ship. It is the distance between the metacenter and the center of gravity of the ship. The metacenter is the intersection of the point of the center line or the ship's when it's upright and the center line when it's held. By carefully managing the position of the center of gravity, center of buoyancy, and metacentric height, naval architects and engineers can ensure that a ship maintains its stability even under challenging conditions. This involves optimizing the designs, weight distribution, and ballasting systems of the ship.
Certainly, let's provide a detailed explanation of how Archimedes' principle is applied to enhance ship stability, including the balancing of weight and buoyant force, as well as the role of ship design and materials in enhancing stability. Number 1. Balancing weight and buoyant force. Archimedes' principle plays a crucial role in enhancing ship stability by balancing the weight of the ship with the buoyant force exerted by the water. Here's how it works. Weight. The weight of the ship includes the hull, machinery, cargo, fuel, and other onboard equipment. The weight acts downward, trying to pull the ship towards the water surface. Buoyant force. Buoyant force is the upward force exerted by the water on submerged portion of the ship's hull. According to Archimedes' principle, the buoyant force is equal to the weight of the water displaced by the ship. To enhance stability, the weight and buoyant force must be balanced. This is achieved by carefully managing the distribution of weight within the ship. By placing heavier components lower in the ship's hull, the ship's center of gravity is lowered. This lowers the overall weight and helps counterbalance the buoyant force, making the ship more